Today we are doing a dilution lab where we calculate the density of various concentrations of a sugar stock solution using two equations. Density equals mass divided by volume, and mass 1 times volume 1 is equal to mass 2 times volume 2. This equation represents the inverse relationship between adding solvent to a solution and its concentration. M1 and V1 represent the concentration of the stock solution, or whatever you're starting out with. M2 and V2 represent your dilution, or what you have after adding solvent, in our case, water. The materials we will need for this lab include a balance, a 25 milliliter volumetric flask, 5 milliliters of the 20% stock solution, a beaker of water, 50 milliliter beakers, disposable pipettes, and a graduated pipette. First, our lab members washed our hands, and then we proceeded with pouring about 25 milliliters of our stock solution into a graduated cylinder. Now I want to take the time from this extra footage to talk about the prep that we did before starting the experiment. We had to decide what volumes of each concentration we wanted to make. These should be reasonable based on the amount of stock solution we were starting with, which was 25 milliliters, so we may want to go down to 20 milliliters, then 15, etc. We'll show what we actually did later on in this video. As we add water to the concentrated sugar stock solution, the volume of the dilution, V2, increases. If M1 times V1 equals M2 times V2, then M2 must be less than M1. After that, we transferred the solution into our 25 milliliter volumetric flask with disposable pipettes to ensure accuracy. We were able to double check the amount of our stock solution by measuring the bottom of the meniscus created by the liquid inside. The meniscus is a curve on the surface of a liquid solution when it touches another material, which is created by polarity. For example, water molecules are attracted to the molecules on the wall of a glass beaker, but the water molecules are also attracted to each other and tend to stick together. When the water touches the glass, it pulls the additional water molecules up along the side of the glass, creating a small dip in the center, which is the meniscus. Using the density equation from before, we can calculate the density based on mass of the solution, using the difference of the masses of the volumetric flask before and after putting the stock solution in, as well as using the volume of 25 milliliters. Using the calculations from before, we know that 15 milliliters of our 20% solution will be combined with water to produce 20 milliliters of 15% solution. Rinse the graduated pipette with the stock solution to decrease the amount of contamination in our calculations and solutions. Using the bulb, extract solution from the stock solution and into the graduated pipette. Record the volume extracted based on the bottom of the meniscus, estimating one more decimal than is definitive, in this case to the 10th, and transfer to a new beaker whose mass has been recorded. Do not empty the graduated pipette completely. Record the volume of solution remaining in the graduated pipette and determine the volume of solution delivered into the beaker. Do this as many times as needed to get the intended volume, then add water until the solution is at the new volume. Weigh the solution, subtracting the beaker's original mass to get the mass of the solution. Repeat the procedure of the first dilution for each concentration, 15, 10, 5, and 2%, and their predicted volumes calculated previously using the dilution equation. In total, there should be 4 dilution procedures, one for every predetermined concentration. Afterwards, using the calculated values for mass and volume, calculate density for this sugar solution, followed up with creating a graph comparing concentration on the x-axis to density on the y. After the experiment is over, we begin the cleanup process. First, we properly dispose of the solutions down the drain after checking with our lab proctor about the appropriate disposal method. It is important to note that not all solutions can go down the drain, and some must be disposed of in their proper chemical waste containers. After disposal, we cleaned, dried, and put away materials in their proper areas. We then followed up with wiping down the lab experiment area with paper towels and water. Note that this is not how one cleans up every single lab experiment, so follow up with your lab proctor for specific cleaning instructions. Lastly, remember to keep your goggles on until you leave the lab room. And thank you for watching.